that pump cylinder looks a little bit different than what I've seen on other stainless steel sprayers, is it?
It is. The primary difference, Joe, would be the length or the stroke of the pump itself. The material, of course, is brass. Can't beat that. The thing I'll tell you about the pump assembly, and most people will know this, but it's a good point to make just in terms of understanding how a compressed air sprayer works. The pump assembly doesn't draw chemical into the cylinder itself. The only thing it's going to do on the upstroke is pull air in, outside air, force it into the tank. So the non-return valve on the upstroke of the piston prevents chemical from being drawn up into the cylinder. So the upstroke is bringing outside air in, and then the downstroke, of course, is forcing it into the tank itself. So that being said, the only I would say the only big difference, of course, is stroke. But a neat feature at the end of the day for us with our pump assembly is that we employ a Viton O-ring, which accomplishes all of that work with the least amount of friction. So you've got a smoother operation, less pumping necessary to pressure the tank to a point where you can apply chemical.
In my territory, they call that Viton.
Baton Rouge, they say Viton. Or some variation of that.
But now, from what you said, I should never see any liquid inside that cylinder.
No.
If I do,
exactly,
then there's a service issue.
That's right. That's right. If you ever drew material up into the cylinder itself, it's going to come out through the entry hole that pulls the outside air, as well as between the piston rod. That's going to be a direct indication that your non-return valve has either fell off or has cracked, broke, or in some cases over stress and strain over time. That thing can lose its tensile strength, if you will, the ability to seal at the bottom of the cylinder.
Well, I know that many people have never really liked the plastic cups or the leather cups that some manufacturers use in their pump assembly. Is this Viton seal going to be more durable, last longer than the leather cups and plastic cups?
I think you'll see that for two reasons. First, because by design you've got less stress on that O-ring. An O-ring is a tried and true method of in hydraulics, and in essence we're hydraulicking air here, if there is such a term. But the O-ring is designed for that. By nature, it's designed for that type of work. The second reason you won't see the failure or the tendency for those cups, as if you will, to not perform right is because our pressure relief valve will prevent over pressuring the tank.
Oh, okay.
So traditionally in the past, when you've had failures, it's been because that technician has over pressured that tank, and something has to give. If the check valve in those systems doesn't give, if it doesn't pop off the bottom of the cylinder, the second mechanical thing in the process that would fail would be the curling or the failure of the cup that you're referring to.
Now, I can see from the schematic that this lance has a shutoff in the tip. Can you tell me how that works?
Yeah. I'll do that, but also I want to point out a couple things. The challenge in a compressed air sprayer in this type of application, in a pest control application where you're inside houses, is you have to be able to apply that material and release the trigger and have immediate shut off. Well, if all of that was back here in the valve body, you would still have material that would have to flow through.
Sure.
All the way to the,
yeah, it would keep dripping
into the nozzle. So the challenge is, how do you have a mechanical release back here but a shut off at the end of the nozzle? So that challenge is met by having a cable inside the lance that's actuated by the trigger movement and is seated and stopped by that valve right there, or that seat, which fits or is fitted into this valve body, the valve seat. So that movement back and forth, when that trigger is depressed, pulls that cable back, opens that seat up, and allows for the flow of chemical. Then when it's released, it goes back into the seat, stops the flow of chemical. So that lance is pressured from valve body to tip end.